Hello everyone, welcome to Ferdinand Tutorials. So in this video, we'll be looking at 40 questions in chemistry. To be a revision question, are you a student writing JAMB or WAEC? Don't skip this video. Make sure you watch to the end so that you understand what these chemistry questions look like and how to solve them. Let's look at question 1. Zinc oxide is a dash: A, basic oxide; B, acidic oxide; C, amphoteric oxide; D, neutral oxide. Let's look at first off, what is a basic oxide? Now we're talking about basic oxide. Basic oxide are oxides of metals. They are oxides of what? Of metals. Oxides of metals. What are the oxides of metals that we have? Examples of metals. We have something like sodium. So when we have sodium plus oxygen is what? Sodium oxide. Sodium oxide is what? Is a basic oxide. Calcium oxide, is what? Is example of what? A basic oxide. Now we begin to look at magnesium oxide. Magnesium oxide. Those are what? Examples of what? Of a basic oxide. When we're talking about acidic oxide, acidic oxide are oxides of non-metals. Oxides of non-metals. Oxides of non-metals. Are we together now? Examples, we have something like your C, carbon plus oxygen oxide, CO2. We have NO2. Are we there now? Those are oxides of non-metals. Then when we're talking about amphoteric oxide act as both acid and as base. So we usually use metal and what? Or metalloids to form this what? Amphoteric oxide. So examples of amphoteric oxide, we have what we call zinc oxide, aluminium oxide, Al2O3. Are we there now? Good. So those are what? Examples of what? Of this particular oxides. Are we there? Now when we come to neutral oxide neither behave as an acid nor as a base. So we have example CO, NO. Are we there now? N2O. Are we together now? They neither behave as an acid nor as what? As a base. So we call them what? A neutral oxide. So if we come here now, zinc oxide is actually found in what? In amphoteric oxide. So the correct answer is what? Is C. C is our correct answer. Now when we come to question 2, we say that the periodic classification of elements is an arrangement of the element in order of their A, atomic weight; B, isotopic weight; C, molecular weight; D, atomic numbers; E, atomic mass. Now what we are saying in this question, they are saying among the 118 elements in the periodic table, how do we arrange those particular elements? Do we arrange them according to their weight, isotopic weight, molecular weight, atomic numbers, or atomic mass? Now if you look at the group of elements, we have element 1, element 2, element 3. Like the simplest one is when they ask you to learn your first 20 elements. You will see that elements are arranged according to their what? According to the atomic numbers. That's why we have element 1 is hydrogen, element 2 is helium, element 3 is lithium, element 4 is beryllium, up until we reach to the what? 118 elements. So elements are arranged according to their what? Atomic numbers. Are we there now? Let's look at question 3. In question 3, it says, in the reaction between sodium hydroxide and sulfuric acid solution, what volume of 0.5 molar solution of sodium hydroxide would neutralize 10 cm³ of 1.25 molar solution? For us to hear about neutralize, that is what? A neutralization reaction. What is a neutralization reaction? A neutralization reaction is a reaction between an acid and a base to form salt and water. So in this scenario now, there is a base. What is our base? Sodium hydroxide. What is our acid? Our acid is what? Sulfuric acid. So they must react. The first rule of neutralization before you solve any question is that you balance the reaction. So for us to balance the reaction, I'm going to say, now I'm coming here. Let me mark this here. I'm going to say, what is the acid? H2SO4, which is the acid, react with sodium hydroxide, which is the base. I must form a salt and a water. What is my salt here? My salt is going to be Na2SO4 and then H2O. Let's balance. H2 is here, H2 is here. Sodium is 2 here, sodium is 1 here. So that means I'll make this to be 2. If I balance it, check. H2, how many H do we have here? 2 plus 2, 4. How many H do we have here? 2. So that means I'll add 2 here. Are we there now? So I will have 4 hydrogen, 2 and 2, 4 hydrogen. How many sulfur? 1 sulfur. Am I right? How many oxygen? 4 plus 2, 6. How many oxygen? 4 plus 2, 2 times O, 6. Are we there now? So it's balanced. So that means the ratio of acid to base is 1:2. So the number of moles of base is 2. The number of moles of acid is 1. So we use the formula for neutralization reaction. We say CAVA over CB VB is equal to NA over what? Over NB. What is the CA? In this particular solution, if we come here, CA simply means concentration of acid, VA volume of acid, CB concentration of base, VB volume of base, NA number of moles of acid, NB number of moles of base. So in this scenario now, we're going to identify what is our CA. Look at the question. In the reaction between sodium hydroxide and sulfuric acid solution, what volume of 0.5 molar solution of sodium hydroxide? So that means our CB is 0.5. So we say CB is equal to 0.5 mole. Now we come here, they say 0.5 molar solution of sodium hydroxide would exactly neutralize 10 cm cube of sulfuric acid. So that means volume of acid is what? 10 cm cube. Concentration of acid, Ca, is what? 1.25 mole. But they didn't give us volume of base because that's what they asked us. They said what volume of 0.5 molar solution of sodium hydroxide. So they're asking us of what? Volume of base, which is Vb. So we say Vb is equal to what? Unknown. Remember here I told you the number of acid is 1. Na is what? Is 1. Nb will be what? Nb will be 2. So we impute. We solve. Anywhere we see Ca, what am I going to put here? Anywhere I see Ca, I'm going to put 1.25 times, anywhere I see Va times 10 all over. Anywhere I see Cb, what am I going to put? Cb, I'm going to put 0.5. Vb is unknown. That's what we are looking for. Vb is equal to, anywhere I see Na, number of acid, 1. Anywhere I see Nb, number of base, 2. Are we there now? So we say this is the same thing as 1.25 times 10, because this is 10. If we move to the nearest into 1 here, it will be 12.5 all over 0.5 Vb is equal to 1 over 2. So I will say I will cross multiply to make Vb the subject of the formula. When I cross multiply, I will have 12.5 times 2 is equal to 0. Any value that is multiplied by 1 will still give you that same word, that same value. So 0.5 Vb times 1 is 0.5 Vb. 12.5 times 2, it should give me 25. Yes, 25 is equal to 0.5 Vb. Such that Vb will be equal to 25 over 0.5. 25 over 0.5 is 10 to 25 over 1 over 2, which when you turn it together, it will be 25 times 2. Therefore, Vb is equal to what? 50 cm cube. Are we there now? That is that. So if you do 25 over 0.5, it will give you what? 50 cm cube. Let's check. Do we have 50? So our answer here is what? Is E. Are we together now? So that is the volume of the base. Are we together now? Now let's move on to the next question. It said the oxidation state of chlorine in potassium chlorate is dash. What is potassium chlorate? Potassium chlorate is KClO3. Are we there now? KClO3. So for us to calculate the oxidation state, we need to understand some things. Now this is potassium. The oxidation state of potassium is +1. Are we there now? The oxidation state of what? Potassium is what? +1. The oxidation state of oxygen here is -2. So we are looking for oxidation state of chlorine. So what do I do? Since K is +1, someone will ask, how do I know that it's +1? What is the atomic number of potassium? Atomic number of potassium is 19. Are we there now? So potassium calcium. So it's 2881. This one is what is willing to give out. Because it can readily give out this particular 1 electron. So the state is usually, that's why we write K as K+. Are we there? So the oxidation state is 1. If I come to oxygen, so I can, this is the same thing as K+, because the oxidation state is what? 1. If I come to oxygen, what's the configuration of oxygen? Oxygen is 2,6. Are we there now? 2,6 simply means that in the octet structure, it needs 2 more electrons to complete its octet structure. Like something like this. This is 2. And for 8, we have 2, 2, 2. So it needs to complete this octet structure. Oxygen needs 2 electrons. So because it needs 2, that it will readily accept 2. So we usually write oxygen as O2-. Anyone that will receive is minus. Anyone that will give in chemistry is what? Is plus. So in this scenario, oxygen is what? 2-. That's why oxidation state of oxygen is usually what? 2-. So if we input it here, anyway I see K, I'll put +1. So I'll say +1. Are we there now? Plus. Chlorine is what I'm looking for. Chlorine plus. Anyway I see oxygen, -2. So I'll put minus 2 because oxygen is into 3 to minus 2 times 3. Are we there now? So I'm going to have plus 1 plus chlorine plus, remember this will be equal to 0. This will be equal to 0. So plus minus 2 times 3 minus 6. So I'm going to say plus 1 plus chlorine minus times plus, I will have minus 6 equals 0. All of this is equal to 0. So I'll come here. Since I have plus 1 chlorine minus 6 equals 0, I will collect like them. So I will say plus 1 come together here. Plus 1 minus 6. What will I have here? I will have minus 5. So I will have Cl minus 5 is equal to 0. Because this is plus 1 and it will come here. Plus 1 minus 6 is minus 5. So Cl minus 5 equals 0. So that Cl will be equal to, this one crosses the equality sign. It will be plus 5. So the oxidation state of chlorine here is what? Is plus 5. So D is my answer. Are we together? I hope you are following. Now in question 5, it says the reaction between an organic acid and an alcohol in the presence of an acid catalyst is dash. Now the state number A is saponification, B dehydration, C esterification, D hydrolysis, E hydration. Now, just as we usually do in JAMB, first of all, we need to identify, these particular options. Why are they here? And then we pick out the right answer. If you're talking about hydration, hydration is addition of water into a molecule. We are trying to make it to be wet. Hydration simply means what? Addition of water to a substance, which is not what they are telling us here. They are telling us an organic acid and what? An alcohol. So when we come to hydrolysis, that means hydration is out. Hydration is out. Now, if we come to hydrolysis, what is hydrolysis? Hydrolysis is splitting of substance by addition of water. Are we there now? So we use water to split substance. That's hydrolysis. Hydro is water. Lysis is what? Splitting, which is not correct answer. Now, if we come to dehydration, let's leave this one and go to dehydration. Dehydration simply means using acid, to dry a substance. Are we there now? So I can add H2SO4, in a particular substance, and then I'll use it to dry that substance. So H2SO4 is a dehydrating agent. Are we there now? So dehydration is ability to dry a substance, no longer hydrating. Dehydration is the opposite of what? Hydration. Hydration is addition of water molecule. Dehydration is what? Removal of water. Are we there now? So if we come to saponification, what is saponification? Saponification is a method whereby we use to form our soap. The reaction of saponification is something like this. Where we said that we have an ester. Ester, example of an ester here can be triglyceride. Ester plus 3 moles of sodium hydroxide. Are we there now? To form a soap plus glycerol. This particular reaction is called what? A saponification reaction. A reaction whereby an ester, are we there now, react with sodium hydroxide to form a soap and what? Glycerol. The method, the reaction that helps us to form a soap is called what? Saponification reaction. Ester, sodium hydroxide. So meanwhile, if we come to esterification reaction, in esterification reaction, we're talking about alkanoic acids. Let's take for instance, maybe CH3, COOH. This is an alkanoic acid. Alkanoic acid has the general formula RCOOH. This is what? Alkanoic acids. So alkanoic acid. So I can say alkanoic acid plus, we try as much as possible to say react with an alcohol. Alcohol, let me use ethanol, C2H5OH. Now when they react, they are going to form an ester. The ester they are going to form can be something like this. Let me use for instance, let's say we have CH3COO C2H5 plus H2O. So in esterification reaction, we're saying is a reaction that involves an alkanoic acid. Alkanoic acid react with an alcohol to form an ester plus what? Water molecule. This particular catalyst here is what? We use acid. We can use mineral acid like H2SO4 as a catalyst. Are we there now? So if we come here, the reaction between an organic acid, what is an organic acid here? Alkanoic acid. And an alcohol, what is the alcohol here? C2H5OH. In the presence of an acid, are we there now? It's called what? Esterification reaction. Esterification reaction. So the correct option here is what? C, esterification. Now, if we come to question 6, now in question 6, they said the IUPAC names of the compound. What is the meaning of IUPAC? Can you remember? International Union of Pure and Applied Chemistry. IUPAC, International Union of Pure and Applied Chemistry. That is IUPAC. So we say the IUPAC names of the compound CH3COOH and CH2 double bond CH2 are respectively dash A. Acetic acid and ethene, B. Methanoic acid and ethene, C. Methanoic acid and ethylene, D. Ethanol and ethene, E. Acetic acid and ethylene. Now, that is what we call a common name and an IUPAC name. If I come here, the common name of this particular compound here, the common name is acetic acid, CH3COOH. The common name is what? Acetic acid. Acetic acid. When we're talking about common name are the name, those that are selling it in the labs usually know it as names that common man call it. So it's acetic acid. The IUPAC name is ethanoic acid. Ethanoic acid. If I come here, CH2, double bond CH2. The common name is ethylene. The IUPAC name is ethene. Are we there now? If we come here, we begin to see that methanoic acid, when we're talking about methanoic acid is just HCOOH. This is what methanoic acid looks like. Are we there now? This is methanoic acid, HCOOH. Are we together now? So in this scenario, ethanol and ethene is out. Acetic acid and ethylene, because both of them are common name. They have the same molecular formula. If you look at this E, they are the same thing. No? This is acetylene, acetic acid. This is ethylene. So this is the name. But this particular one is common name. So it's out. It's the common name. Because of the ethylene, the ethylene is common name. If we come to number C, methanoic acid and ethylene, this is not methanoic acid, as I told you earlier. So it's out. If you come to number B, methanoic acid and ethene is also out. But if you come to A, they are asking us of IUPAC name. That means they didn't even write the IUPAC name. So they gave us one common name and one IUPAC name. So we're going to go with this particular man, A here. Are we there now? But had it been we had ethanoic acid and then ethene, we're going to choose ethanoic acid and ethene because acetic acid is the what? Is the common name. Are we there now? But since there is no ethanoic acid here, we only saw acetic acid. So we'll go with common name and IUPAC name as opposed to common name. Are we there now? So that is why we'll go with this particular A. A is the what? A is the answer. It says if 30 cm cube of oxygen diffuses through a porous pot in 7 seconds, diffuses through, we're talking about Graham's law of diffusion. Are we there now? How long will it take 60 cm cube of chlorine to diffuse through the same pot if the vapor density of oxygen, are we there now, and chlorine, this is oxygen, and chlorine is 16 and 32. First of all, we use the Graham's law of diffusion. We say R1 over R2 is equal to root M2 over what? Over M1. Are we together now? Now, what we're going to do here is that we're going to say M2 is molar mass, M1 is molar mass, R1 rate of gas 1, R2 rate of gas 2. Are we there now? And we also say that rate is equal to volume over what? Over time. Volume over time. And we also say that molar mass is equal to 2 times vapor density. Now, for us to calculate the molar mass of gas 1, remember gas 1 here is the first gas that was mentioned. So gas 1 is our oxygen. Gas 2 is what? Chlorine. The first gas that was mentioned in the question is usually your gas 1. The second gas that was mentioned is your gas 2. So in this scenario now, we want to say R1 over R2. We don't have rate. We don't have molar mass. So let's start looking for them. Let's first of all calculate the mass of gas 1. Anywhere we see gas 1, we're talking about mass of oxygen. So molar mass of oxygen will be equal to 2 times vapor density. What is the vapor density of oxygen? Oxygen and chlorine is 16 and 32. So we say 2 times 16, which is equal to what? 32 grams per mole. Now, what is the molar mass of chlorine gas? 2 times vapor density, 2 times 36, which is equal to what? 72 grams per mole. Now, in this scenario now, we want to calculate our rate. So let's say rate of oxygen. Rate of oxygen. What is the volume of oxygen? 30 cm cube. What is the time of oxygen? 7 seconds. So 30 over 7. We'll have 30 over 7. Okay. 30 over 7, which is 4.286. 4.286. Now remember that this rate will be cm cube per second. So this is cm cube per second. Now for rate of chlorine, because they're asking us for rate, if you look here, the time of this particular chlorine was not given. So that means at the end of the day, we're expected to solve for the time of chlorine. And we're going to use this formula also. Rate of chlorine is equal to volume of chlorine all over time. So because time was not given, we'll find the rate. When we get the rate, we'll impute the rate here and make time the subject of the formula. So we can get our time and choose the right answer from here. So let's start solving. I will say, anyway, I see R1, I'll put rate of oxygen. What is my rate of oxygen? 4.286. Anyway, I see R2. What will I put as my R2 now? My R2 is unknown, rate of chlorine. Anyway, I see M2. What will I put as my M2, which is mass of chlorine, 72. Anyway, I see M1, which is molar mass of what? Of oxygen, which is what? 32. I'm not talking about mass, molar mass. Please don't make a mistake. Molar mass. So I'm going to say 72 over 32. I will have 72 over 32. I have 2.25. 2.25. So I'm going to say 4.286 over RCl2 is equal to root 2.25. Root 2.25 is equal to 1.5. Please look up, no mistake. I'll cross multiply, making RCl2 the subject formula. So RCl2 will be equal to 4.286 over 1.5. So 4.286 over 1.5. I'm having 2.857. So 2.857 cm cube per second. That's my rate. So remember what they ask us to say. They say, how long is time? They're asking us of the time of chlorine. So since we've gotten our rate of chlorine, we'll now say rate of chlorine is equal to volume of chlorine all over time of what? Time of chlorine. Look at what they ask us to find in the question. So we'll make time of chlorine the subject of the formula. So I'll say time of chlorine is equal to volume of chlorine all over what? Rate of chlorine. Are we there now? Anyway, I see volume of chlorine. What am I going to put here? 60 cm cube. Because they say how long will it take? 60 cm cube of chlorine. So that means volume is what? 60 cm cube. So I'm going to say 60 over. What is my rate of chlorine now? 2.857. So I will say time of chlorine is equal to, I will say 60 over 2.857. I'm having 21.00 seconds. Look at the option here. We have 21, which is C. So my correct option, because my correct answer is what? Is C, 21.00 seconds, which is 21 seconds. I've calculated the time. Are we there now? Now, let's move on to question 8. It says, an example of alcohol is dash. They give CCl4, CH3COOH, CHCl3, C2H6, CH3OH. First of all, I want you to understand that when we're talking about alcohol, alcohol has the general molecular formula ROH, where R is the alkyl group, OH is the what? Functional group, which is hydroxy group. Are we there now? So R can change. R can be methyl, R can be ethyl. Are we there now? What is the general formula for R? R is CnH2n plus 1. Are we there now? So I can have methyl. If I have methyl, methyl will be CH3 plus OH, which is CH3OH. Are we there now? If I have ethyl, ethyl will be C2H5OH, which is ethanol. This is methanol. This is ethanol. I can continue propanol, butanol, pentanol, hexanol. Are we there now? So there must be methyl and then there must be one, just single OH. So where can we find single OH? Not here. Now, when we have CH3OOH, this is an alkanoic acid. What is the formula for alkanoic acid? RCOOH. The difference between this and this is that this is an alkanoic acid. The functional group here is COOH. This is an alcohol. The functional group here is what? OH. So this is an alkanoic acid, which is an ethanoic acid. Are we there now? This is chlorine and CH, C2H6, ethene. This is what? The alcohol. Methyl and OH, which is what? Methanol. Are we there now? So that is it. Let's move to question 9. Okay, to question 9, it says, which of the following is not a member of the homologous series of alkanes? before we even solve this question, I want you to understand that when we're talking about alkanes, alkanes are, they have the general formula CnH2n plus 2. If we're talking about alkenes, just to shed a little more light, alkenes are CnH2n. If we're talking about alkynes, which are triple bond, is CnH2n minus 2. Now, let's leave all this. Since we're talking about alkanes, that means if C is 1, H will be 2 times 1, 2 plus 2, 4. So that means when we have C, 1C to be CH4. When we have 2C, it will be C2H6. If I have 3, it will be C3. Instead of having C3H6, I will have C3H8. Are we there now? We can calculate. Let's calculate using the formula. If n is 1, I will have C. N is 1, it will be C. N is 2 times 1, 2 plus 2, 4. So CH4 when n is equal to 1. Are we there now? Remember that how we know when n is 1 is that carbon will bear the number of n. Are we there now? Whenever carbon bears a particular number, we'll use that number as our n. So when we have n is 5, carbon will be C5. So my head will be 5 times 2, 10 plus 2, 12. Are we there now? When n is what? Is 5. Now in this scenario, since we have C3, let's check if the number of hydrogen is balanced here. So we say C3 will be 3 times 2, 6 plus 3 plus 2, 8. So C3H8 when n is 3. Now, let's come to this man here. N is 5. So we say C5H. H will be 2 times 5, 10 plus 2, 12. Are we there now? When n is what? 5. So it's correct. Let's come here when n is 7. We come here C7H. 7 times 2, 14 plus 2, 16. C7H16. Are we there now? So this is correct too. When n is what? Is 7. When n is 7. Now when n is 15, we say C15H. 15 times 2 is 30 plus 2, 32. C15H32. When n is what? Is 15. So this is correct. When n is 24, so we say C24H. 24 times 2 will be 48 plus 2, 50. C24H50. Are we there now? So this is the one that is not correct. So which of the following is not a member of the homologous series of alkane? The answer is our E. Are we there now? Because it was supposed to be C24H50 when n is what? When n is 24. I don't know if you are getting what we are saying here. Now, question 10. It says, consider the following equation. Look at the equation. H2O plus 2Fe2 plus Cl2 will give us Fe3 plus 2 moles of Fe3 plus 2Cl minus plus H2O. They say which of the following component is an oxidizing agent? I usually tell my students, say, when we're solving about oxidizing agent and reducing agent, both oxidizing agent and reducing agent are seen towards the reactant. They are located at the what? At the reactant side, not at the product side. Are we together now? Even though this is a forward and backward reaction, as you can see in the arrow here, but we look the reactant, the oxidizing and reducing agent are usually located at the what? At the reactant. So in this scenario, what we are talking about, let's look here. Let's start with ion, because in oxidation and reduction reaction, we're talking about change of oxidation state. So first of all, here we have ion increased from ion in the reactant here, ion increased from 2Fe2 plus to 2Fe3 plus. So that means there is an increase in oxidation state. So if there is an increase in oxidation state, ion undergoes what? Oxidation. Are we there now? Ion undergoes what? Oxidation. And at thus, ion here, ion 2 plus, is what? A reducing agent. Is what? A reducing agent. So they didn't ask us of reducing agent. They are asking of oxidizing agent. So let's check for chlorine. Chlorine here moved from Cl2 to 2Cl minus. Now, I usually tell my students, I say, whenever we have an element, either monoatomic element or diatomic or even triatomic element, stay on its own, the oxidation state is usually 0. Are we there now? Here is minus. So when chlorine moves from 0 to minus, are we there now? There is a reduction or decrease in oxidation state. So that means this chlorine undergoes what? Reduction. Chlorine undergoes what? Reduction. And at thus is called what? An oxidizing agent. And at thus is called what? An oxidizing agent. So Cl2 here is the what? Oxidizing agent. Let's look at question 11. It says 56 cm cube of a gas at STP weighed 0.11 gram. What is the vapor density of the gas? Molar volume of gas at STP equals 22.4 dm cube. Since they're asking us of vapor density, remember I told you that molar mass is equal to 2 times vapor density. So to make vapor density the solution formula, I'll say vapor density is equal to molar mass over what? Over 2. Are we there now? And then remember, to calculate our molar mass, I usually say molarity is equal to what? Mass all over what? All over molar mass. If you look at the question, what we are looking for here is molar mass, because I will need my molar mass to calculate my vapor density. I already have my mass, which is 0.11 gram. So I want to calculate my molarity. Now, since they gave me volume and then they gave me, volume at STP, I will use the formula molarity is equal to volume or actual volume all over what? Molar volume at STP. Molar volume. Are we there now? Now, you say volume because they say at STP, they say volume at STP all over what? All over molar volume. Now, volume at STP, the volume at STP they gave me was 56.00 cm cube. Because my molar volume is 22.4 dm cube, I will have to convert this man to dm cube. So cm cube to dm cube, are we there now? I will divide by 1000 because 1000 cm cube is tempted as 1 dm cube. Are we there now? So 1000 over 1000, 1 dm cube. So 56 cm cube will be 56 over 1000. So I would say molarity here, 56 over 1000, 56 over 1000. I'll have 0.056 dm cube. So I will say molarity is equal to 0.056 all over 22.4 dm cube. So I will say 0.056 over 22.4. What do I have? 0.0025. Am I right? 0.0025 moles. Are we there now? Now, if I impute this molarity here, I will make molar mass the subject of the formula. I will now say molar mass is equal to mass over molarity. Anyway, I see mass, what will I put? Let's use mass over molarity. Are we there now? Now, what is my mass? 0.11 gram. What is my molarity? 0.0025. So I will say 0.11 over 0.0025. What do I have? So my molar mass is equal to what? 44 grams. Molar mass is equal to 44 gram per mole. So to calculate my vapor density, I will say vapor density Vd is equal to molar mass over 2. That means 44 over 2, which is 44 over 2, which is what? 22.00. So if I come here, where do I have, what is my vapor density? My vapor density here is what? 22.00. Are we together now? So this is, my answer. Are we together now? Good. Don't mind this unit that they put here in chemistry. I'm surprised they added cm cube because vapor density is not a cm cube. Are we there now? But all the same, let's leave it as this. But look, this is the answer, 22.00. Now let's move on to question 12. Now in question 12, they say the most common types of chemical reaction, which alkanes, remember alkanes are usually saturated. So alkanes are CnH2n plus 2. Let's take for instance ethane, C double bond, C single bond, 2, C. This is H, 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 and H. This is what? This is ethane. Are we there now? This is an example of an alkane. Now in alkane, this is alkene. Let's draw alkene. This is alkene. Are we there now? Alkenes are unsaturated. So when we are talking about reaction that alkanes undergo, alkanes do not undergo polymerization reaction. What are polymerization reaction? Polymerization reaction are reaction whereby we bring compounds together. Are we there now? To form a polymer. Are we there now? We bring simpler molecule together to form what? A polymer, a giant molecule. Now, if you're looking at, a reaction an alkane undergo, it's usually substitution reaction, because it's in alkane that we can come here and then we remove H and add Cl. Are we there now? Or we remove this particular H and then we have what? Cl. When we have what? Chloro, you understand? Chloroethane. Or in this scenario now, we have 1,1-dichloroethane. Are we there now? 1,1-dichloroethane. So this is substitution reaction, trying to take out one and replace it with another. That's substitution. So alkanes generally undergo what? Substitution. Addition reaction is only happens in an unsaturated compound, where we have to add more compound to make this man to be saturated, because already here is unsaturated. So if I want to add, I will add a substituent. Maybe I'll add another hydrogen or add another chlorine to help it to be what? To be saturated. So alkene undergoes what? Addition reaction. So the only reaction alkanes undergo are what? Substitution reaction, because they do not need you to add or remove. What they just need you is, if you are taking out something, you are replacing. That is what? Substitution reaction.
Let's look at question 13. Now in question 13, it says, which of the following gases will diffuse fastest when passed through a porous plug? Now they give us the molar mass of hydrogen, molar mass of carbon, nitrogen, and oxygen. Now, how do we solve this question? Now, remember, for us to have diffuse through a porous plug, we're talking about Graham's law of diffusion. And when we're talking about Graham's law of diffusion, we say that Graham's law of diffusion says that the rate of diffusion of a gas is inversely proportional to the square root of what? Of their gases. Are you getting what I'm saying? That is to say, we say R1 over R2 is equal to root M2 over what? Over M1. That means the rate of diffusion increases as the molar mass of the gas decreases. Are we there now? So that means a gas with a molar mass of 5 will have an increasing rate of diffusion than a gas with a molar mass of 50. Are we there now? So that means the lesser the molar mass, the higher the diffusion rate. Are you getting what I'm saying? The lesser the molar mass, the higher the diffusion rate. Are we together now? So that means if I come here and then, we're asking about the gas that will diffuse fastest, we are looking at the particular gas here that has what? The lowest molecular mass. Because for you to diffuse faster, you must have what? A lower molecular mass compared to the others. So if we come to propane here is C3H8. What is the molar mass? It should be 12 times, because carbon is 12 from what we have here, times 3 plus, what is hydrogen? 1 here. So 1 times 8. Are we together now? So we're going to be having 12 times 3 should be 36 plus 8, which is what? 44 grams per mole. Are we together now? Now if we come to oxygen gas, oxygen is O2. Remember, anywhere we see O is 16. So it's 16 times 2, which is what? 32 grams per mole. 32 grams per mole. If we come to methane, methane is CH4. That is to say, anywhere I see carbon is what? Carbon is 12. Plus, anywhere I see hydrogen, 1 times 4. So it will be 12 plus 4, which is what? 16 grams per mole. Are we there now? Now, if we come to ammonia, ammonia is NH3. Anywhere I see N is 14. 14 plus 1 times 3, which is 14 plus 3, which is 17 grams per mole. According to what I said that the lesser the molar mass, the higher the diffusion rate. So if we come here, here is 44, here is 32, here is 16, here is 17. Which one has a lesser molecular mass? It is what? Methane. So the answer is what? Methane. The gas that will diffuse faster here is what? Is methane. Good. So if we come to question 14, it says, which is the temperature of a given mass of gas initially at 0 degrees C at 9 atm if the pressure is reduced to 3 atm at constant volume? Okay, so they're asking us of temperature 2. And if you look at a particular, gas equation, there are 3 important gas equations I want us to look at as beginners here. We have Boyle's law, which is P1 V1 equals P2 V2. This is Boyle's. Are we there now? This is Boyle's. Now, we have V1 over T1, which is equal to V2 over what? Over T2, which is what? Charles. Are we there now? We have combined gas equation, which is P1 V1 over T1 equals P2V2 over what? Over T2. Are we there now? So if you look at, this is 2. If you look at this particular equation, these three equations, this is combined gas equation, combined gas equation. If you look at these three equations, you begin to see that, there is no particular place where we have only temperature and pressure. There is no place. What we have is pressure and volume and temperature. So that means we are using neither of these equations to solve. But we're going to use equation 3 because if you look at this, they say temperature and what? And pressure. Volume was constant. So what we are going to be using, we are going to be using this particular formula. Since volume is constant, we're not going to be using volume. So we are going to be using P1 over T1 is equal to P2 over what? Over T2. Anywhere we see P1, what are we putting in P1? P1 is 9 atm. So we are going to say 9 over, anywhere we see T1, T1 is 0 degrees. So we use 273 Kelvin over 273. Are we there now? Is equal to 0 degree to Kelvin is 273. Are we there now? Good. So equals, what is my P2? P2 is going to be 3 atm. 3 over T2. So I will cross multiply. I will say, I will have here 3 times 273 is equal to 92. So we have therefore 92 is equal to 3 times 273. 3 times 273. What do we have? 819. 819. So that means T2 will be equal to 819 over 9. So 819 over 9 is equal to 91 Kelvin. So my T2 is equal to what? 91 Kelvin. So my correct option here is what? A. Let's look at question 15. Now, in question 15, it says a gaseous metallic chloride, MClX, consists of 20.22% of M by mass. The formula of chlorine is dash. They give us the molar mass of that M, which is 27, the chlorine mass, which is 35.5. Now, for us to calculate the formula or identify the formula, what we're going to do is that we use the empirical formula knowledge, where we bring out the elements involved, element M and element what? Cl. Now, they told us that 22.22% of M was given by mass. So what they are telling us is that this is 22.22 grams in a nutshell. Are we together now? So we are going to say 20.22. Now, to calculate the remaining mass of this particular chlorine, I'm going to do 100 minus 20.22. That is going to give me 79.78 grams. The next step is that I will divide by their individual molecular masses. So what's the molar mass of M? 27. So I will divide this by 27. What's the molar mass of chlorine? Molar mass is what? 35.5. Are we there now? So when I come here, I will say 20.22 over 27. What do I have? 0.789. 0.7489. If I come here, 79.78 over 35.5. We have 2.2473. 2.2473. Now we divide by the smallest number. What is the smallest number between these two? 0.7489. So 0.7489 over 0.7489. So that this one divided by itself, we have 1. This one divide, we have 2.2473 all over 0.7489. So we having 3.00080. So 3.00. This is the same thing as anywhere I see M, this is M1. Out there Cl, how many moles? 3. This is the same thing as MCl3. This is their what? This is the formula, which is option C, MCl3. Are we together now? So if we come to question 16, it says 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Since an element in the electronic configuration above is dash. Now, when we are asking about elements in the electronic configuration above, what we are saying is this. If you come here, this particular configuration where we have S, P, D, and F is called what? Azimuthal configuration. Are we there now? It's called what? Azimuthal configuration. Now, the maximum number of electrons in S is 2. The maximum number of electrons in P is 6. The maximum number of electrons in D is 10. The maximum number of electrons in F is 14. Are we there now? It must be completely filled for you to go on to the next word, the next orbital. So elements that has S as their electronic configuration are called S orbitals. They belong to S orbitals. Those there, P here, D here, F. Are we there now? So if we come here, we begin to see that, look at these two things here. I said that the maximum number of D is 10, but here we have 7. So that means for you to move on to the next particular, shell, you must completely fill the previous one before you move on. But here we have 7 and then we move to 2. Are we there now? So elements that have their D orbitals not completely filled are called what? Transition elements. Elements whereby the D orbitals are not completely filled, are we there now? Before you move on to the next are called what? Transition element. So in this scenario now, if we come here, elements that belong to D orbitals also are also called what? Transition elements. So if we come here, which is 2, 4, 2 plus 2, 4 plus 6, 10, 12, 18, 20, 27. Are we there now? Which element is up to 27? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt. Cobalt is 27. Nickel, copper, zinc. So cobalt is 27. So since we're talking about, cobalt that is 27, cobalt that is 27 belongs to what? Transition elements. You don't call them transition elements, you call them what? Transition metals. Why are they transition metals? Because they belong to what? D orbitals. Are we there now? If you come here, if I add these two here, it would have been D9. Are we there now? But because this particular, we don't have anything like D9 in electronic configuration, in azimuthal configuration, we don't usually add D9. So we say that this particular element, are what? Transition elements. So instead of adding D9, we'll just move on and add what? 4s2. So I want you to understand that the answer is what? Is C, transition element. It says, the correct order of increasing oxidation number of the transition metal ions for the compounds K2CR2O7, V2O5, KMnO4. That means in each of these compounds, there are what we call what? Transition metals. Remember, in the other question, I mentioned something like transition elements or transition metals. So let's see it come to pass here. So in this situation now, let's bring out the first compound, which is K2CR2O7. So that means the transition metals here is what? Chromium, because this is potassium, K. This is oxygen, O. Are we there now? So to calculate their what? Their oxidation state of this particular chromium, I would say anywhere I see K is plus 1 times 2. Are we there now? Plus 2Cr is tempting as Cr2 is tempting as 2Cr plus minus 2 times 7, which is equal to 0. So I would say 2 plus 2Cr minus 14 is equal to 0. Collect like term. So 2Cr plus 2 minus 14 is minus 12. Is equal to 0. So I would say therefore 2Cr is equal to 12. And then Cr is equal to what? 12 over 2, which is what? 6. That's plus 6. So the oxidation state, oxidation number of chromium, Cr, is what? Plus 6. Now let's calculate that of V2O5. So we'll move to V2O5. Now for V2O5, we'll say anywhere I see V is unknown. That's what I'm calculating for. Oxygen is already what? Minus 2. So I will say 2V plus minus 2 times 5 is equal to 0. So I will say 2V minus 10 equals 0. That means 2V is equal to 10. And V is equal to 10 over 2, which is what? Plus 5. So the oxidation state of this particular transition metal V is plus 5. Oxidation state of this transition metal Cr is what? Plus 6. So let's come to KMnO4. So for KMnO4, I will say anyway I see K is plus 1 plus Mn plus bracket minus 2 times 4 is equal to 0. Are we there now? So I will say plus 1 plus Mn minus 8 equals 0. Connect like them. Plus 1 minus 8 is minus 7. So Mn minus 7 is equal to 0. Equality crosses over. Minus crosses over the equality sign to turn to positive. So Mn plus Mn is equal to plus 7. Are we there now? So if you are talking about the oxidation state, which one has the least to the highest. The least is V2O5, followed by K2CR2O7, which has 6, and then the highest is what? KMNO4. Increasing means what? From lesser to higher. So in this situation now, we're going to say from this, that means V2O5 to which one now? K2CR2O7 to KMNO4. Are we there now? So if we come here, which one follow that order? V2O5 to K2CR07 to KMNO4. The option is what? Is A. Are we together now? I don't know if you are getting what we are doing here. Are you following? If you're not following, ask question now. Are we following? Good. So now the correct order follows with this particular option A. Now if we go to question 18, it says 2-methyl-prop-1-ene is an isomer of dash A, but-2-ene, pent-1-ene, 2-methyl-but-2-ene, 2-methyl-but-1-ene. When we're talking about isomer are compounds that have same molecular formula but different structural arrangement or spatial arrangement. So if we come here, 2-methyl-prop-1-ene, look at what it simply means. Something like this. This is what 2-methyl-prop-1-ene simply means, because prop-1-ene, 2-methyl. How many carbon atoms do we have here? 1, 2, 3, 4. Are we an isomer? They must have the same, molecular formula but different structural arrangement. So molecular formula simply means they will have the same number of carbon, the same number of what? Of hydrogen. Now let's look for compounds in this option that have 4 carbon atoms. First of all, if we come here, this one has 4 carbon, but pent 5, so this one is out. 2-methyl-but simply means 2-methyl and but, which is 5. I would do that because but is the family name plus a branch out, which is 2-methyl, is 5. So this one is out. If we come here, 2-methyl-but-1-ene, 2-methyl simply means methyl and a but, which is 5, is also out. So the only option here is what? A, but-2-ene. So the isomer of 2-methyl-prop-1-ene is still the same thing as what? This is but-2-ene. Are we there now? But-2-ene. It says when 2 N-alkyl groups of ethyl ethanoate are interchanged, the compound form is dash. They say methyl ethanoate, ethyl propanoate, methyl propanoate, propyethanoate. I'll teach you something here. Just work with me, please. Now, when we're talking about ethyl ethanoate, methyl propanoate, that means the compound is what? An ester. What is the general formula for esters? Esters are written as RCOOR. Are we there now? You can say R prime or R, anyhow you want to arrange it. RCOOR. And when naming esters, we start from the back. Are we there now? Whenever we are naming esters, we start from the back. If I have something like R, let me say I have CH3, and then I have COO, and then I have CH3. Remember, this R is methyl, this R also methyl, CH3, CH3. If I want to name this ester, I will start from the back. What I'm going to have here now, I'm going to have, this is my methyl. I will start from the back to name. So I'm going to have methyl. Now, because I have 2 carbon atoms here should have been methyl. But because I have methyl and the functional group, which is C, is now going to be eth. So it's going to be methyl ethanoate. Are you getting what I'm saying? It's going to be what? Methyl ethanoate. If I have something like this, CH3, COO, C2, H5, I'm going to start from the back. Do you remember what I just said? Starting from the back, what's the name of this alkyl group? Ethyl. So if I'm naming now, I'm going to have ethyl from the back. Now, methyl plus C is eth. So it's going to be ethyl ethanoate. Are we there now? So the same, that's how to name esters. So back to the question. When 2 N-alkyl groups of ethyl ethanoate are interchanged, I've just said it here. This is ethyl ethanoate, CH3. Are we there now? COO, C2H5. Are we there now? How do I write ethyl ethanoate? For me to write ethyl ethanoate, I must first of all start from the back. Ethyl, that means ethyl, I'm going to have C2H5. I've written ethyl. So how do I write ethanoate? I will say that, okay, for ethanoate to be formed, we're going to have methyl plus the functional group, which is CH3, COO. Are we there now? So they say when it's interchanged, when the alkyl groups are interchanged, if alkyl groups are interchanged, this will come over here, this will come over here. So I'm going to have something like this, C2H5, COO, C H3. Please, can you name it? This is methyl. Naming it now is going to be methyl, ethyl plus C, prop. So methyl propanoate. Methyl propanoate. So where do we have methyl propanoate? Option C. Are you getting what I'm doing here? I hope you're following, right? Now, if I ask you, how do you write methyl ethanoate? How can you write it out? You first of all see, for me to write out methyl, we've gotten the answer, but I just want to teach you something small. Now, if you want to write out methyl ethanoate, you first of all, we start from the back. So methyl will be at the back, so CH3. If I say ethanoate, that means I'm going to have met plus another carbon, which is the functional group. So I'm going to have CH3COO. Et is 2 carbon atom. Are we there now? So if I have ethyl propanoate, you start from the back. I'm going to have C2H5. Propanoate simply means I'm going to have a total carbon at the end, 3 carbons. So first of all, you form methyl and then 1 carbon. You also have C2H5COO. This is what ethyl propanoate. Methyl propanoate, just as I've said, you have CH3 and then you have C2H5COO. This is it. And then propyl ethanoate, you start from the back. Propyl simply means C3H7. Are we there now? Propyl ethanoate. Ethanoate will now be CH3COO. Are we together now? So this is how esters are, arranged and named. Question 20. It says the knowledge of half-life can be used to create an element, detect an element, split an element, irradiate an element. Now, we use the knowledge of half-life not to create an element. No. We rather use the knowledge of half-life to do what? To detect an element. Are we there now? We don't use knowledge of half-life to split. We use the knowledge of half-life to do what? Detect an element. That is why many questions that we see in our chemistry, they usually say, calculate the half-life. Are we there now? So the simplest formula we use in calculating half-life is T half is equal to ln 2 over what? Over lambda. Where ln 2 is 0.693 over lambda. So we use half-life to do what? To detect an element. So in my next video, I'll be explaining from 21 to 40. So stick to the video. Don't click off. If you love this particular video that you watch, you would like to see how I solve question 21 to 40. I decided to shorten it because of the timing. See you in the other video.